perpendicular bisectors and angle bisectors, right? Now the perpendicular bisector and the median both hit the side of the triangle at that middle point and cut it in half. The difference is with a perpendicular bisector, it has to be 90 degrees. So it's always going to be 90 degrees on a perpendicular bisector, whereas with a median, it has to be connected to the opposite side vertex of the triangle. So it can be any angle coming off of the midpoint. This angle here can be any angle. It just has to go from the corner of the triangle to the midpoint of the other side. And then the centroid is the point of concurrency for the medians. So all of the medians will meet at a single point. And that point right here is the centroid. So far we've got perpendicular bisectors and angle bisectors. Now we have medians. And we had in-center, circumcenter, and now we have centroid. Okay, so perpendicular bisectors gave us our circumcenter. Angle bisectors give us our in-center. Medians give us our centroid. Okay, so we have to keep those together, keep them straight. Okay, so the medians of the triangle all intersect at the centroid, and the centroid is 2/3 of the distance from the vertex to the midpoint. Okay, so if we were to call this distance x, this distance would be 2x, because there, if you broke it into thirds and each third was called x, you'd have one of them on this side and two of them on this side. So if this part here is y, this would be 2y. And if this part here was z, this would be 2z. Okay, because AO is 2/3 of the distance of AE, the whole thing. So if you broke this down in half, you'd have one half that's another x and another x. So you'd have 3 x's, and this is 2 of them, 2/3. Okay. CO is 2/3 of CD. It's an O. And BO is 2/3 of BF. Which means that, like, OE is 1/3 of the way across the whole thing. OD is 1/3 of the way across the whole thing. And OF is 1/3 also. Okay. So if it's easier to remember with the 2/3 fraction thing, remember it that way. If it's easier to remember, like the long part is 2x and the short part is x, remember it that way. However, it's easier for you to remember it. A triangle ABC, Q is a centroid, so that's this point right here is a centroid. What that tells me, as soon as I see centroid, I know that these two lengths are the same. These two lengths are the same, even though it doesn't look like it. These two lengths are the same, because the centroid's hitting at the medians, right? The medians create the centroid, and they're hit at the midpoint. And then what I also know is if I call this x, this is going to be 2x. If I call this y, this is going to be 2y. And if I call this z, this is going to be 2z. Now, how do I know which one's z and which one's 2z? The short side always hits the side, and the long side always hits the vertex. Okay, so that's the part coming out of the vertex, that's the long one. Even if in the picture you can't really tell, because sometimes the pictures aren't drawn properly. Like this one, obviously this is not a midpoint, but okay. So we know that BE is 9. We want to find BQ and QE. So this whole length, BE, is 9. Well, I know this part is 2y and this part's y because I labeled it. So the whole thing together is 9. So 3y is 9, so y is 3. So that means QE is 3. So what's BQ? Well, it's twice that, so 6. Okay. FC is 15, so we're talking about this whole long part right here, FC is 15. So I have x and 2x. So 3x is equal to 15. So x is equal to 5. So FQ is the short part, so that's 5. And QC is the long part, that's twice that, it's 10. PT is 2. That's this part right here. PT is 2. What's KP? KP is how much times 2? Thank you. RP is 3.5. And JP is 9. So we want to find PL and PS. So PL is going to be the long part, so I'm going to multiply 3.5 times 2. And PS is the short part, so I'm going to divide 9 by 2. It's that easy. On this particular triangle, I wasn't told that P is a centroid, but the way I knew it was a centroid is that I went from a vertex to a midpoint on all 3 sides. So that told me medians, which told me centroid. I would like for you guys to try this one. And we will start by first, I'm going to get rid of their 3 and their 4. Okay. And I'm going to label x and 2x, y and 2y, z and 2z. Okay. Oh, darn it, too big of an eraser. My z is not very good. Okay. Now NQ is 6. That's this whole thing. RK right here is 3. And PK right here is 4. So just check your answers. Any questions on this? Another one we'll do is the next group on the. Okay, now because we have a centroid, that tells me these are midpoints. So this is the same length as this. These two are the same, and these are the same. Okay. And then we have that relationship with the lengths of the altitude parts. Okay. H is my centroid. So I have DH is 4. That's this length right here. So I'll just put y equals 4. EH is 6. That's this length right here. And SM, this whole thing, so 3x is going to be 24. So you can use that information and go ahead and try these. Okay. Interesting thing about the centroid is that the centroid is the point of balance in a triangle. So if you had, like, you know how people balance plates on their fingers or on a stick or something and spin the plates or whatever? Well, if you had a triangle and you were trying to balance it, you would need the centroid. Because if you put like a ceramic triangle on your finger on the centroid and you were exactly on the centroid, it would just balance. As long as you didn't, tilt yourself. So it's the point of balance in a triangle. Okay, we can find the centroid of a triangle with the vertices. I'm going to label them. I have -3 and then 15, 1, 5, and 5, 10. Okay. Helps if you hit the right button. So here's our triangle. Now if our triangle was arranged to where it was maybe like a right triangle and I had 2 flat sides, I'd be able to do this just with graphing, or at least 2 parts of it with just graphing. In order to find the centroid, I need to find the midpoint of one of the sides first, because the midpoint is where the altitude, sorry, not the altitude, the median hits the side of the triangle. So I can find the midpoint of any one of these lines. Do you guys want to find XY, YZ, XZ? XZ? Okay. So we're going to find the midpoint of XZ first. Okay, and you remember the midpoint formula is I add the x's, divide by 2, add the y's, divide by 2. Sorry, that's so crowded. I'll rewrite it. Okay, so I'm doing xz, so I'm using this point and this point. So I have -3 plus 5, divide that by 2, and then I have 15 plus 10, divide that by 2. Okay. So this is going to give me 2 over 2 and 25 over 2. And here's where I'm going to say I don't really like this one, because this doesn't divide evenly. But see how I have a 5 and a 15, if I add those together, I'll get a number that'll divide evenly. So I'm going to switch and try that one. And I'm going to do x and y. So I get -2 over 2 and 20 over 2, which gives me -1 and 10. So -1, 10 is my midpoint. Now nicely, that lines up really pretty right here. So this would be my median to Z. Okay. Because this lined up so nicely and gave me a nice straight line that's horizontal, I can count the length of it. Okay. So the second thing you want to do is you want to find the distance between the midpoint and the opposite vertex. If you can get one to be horizontal or vertical. You know, if you need to try all three to try to find one that's horizontal or vertical first, that makes it easier. If not, you have to use the distance formula. Or we can count. Again, we can count if it's horizontal or vertical. And in this case, I can count. So I have 1, 2, 3, 4, 5, 6. Okay. The centroid is 2/3 the way across that. Six divided by 3 is 2. So I need to move 2 over, and I have found my centroid. So 1, 2. There's my centroid right there. And this point is at 1, 10. Okay. Again, I'm going to graph my triangle. So I have 2, 5, 6, 5, and then 10, 0. Now I need to find my midpoint on one of these lines. And if I find the midpoint here, I mean, it's an easier midpoint probably to find. But it's going to be, see how I'm going to get this line that's not flat? So it's going to be hard to find that 2/3 or 1/3 point across. So I'm going to try, let's see, this was S, this is T, and that's R. So I'm going to try TR and SR first to see if I can find a midpoint that will give me kind of a more flat horizontal or vertical line. So I'm going to do SR first, just because I kind of think it'll fall like that. Just looking at the picture, it looks like it's possible. So I'm going to try that one first. So I have 2 plus 10 divided by 2, and 5 plus 0 divided by 2, which gives me 12 over 2 and 5 over 2, which gives me 6 and 2.5, which is probably not going to give me a good thing. So I've got 6, and then I have 2.5. Oh, hey, check it out. It works. I didn't think it was when I got that 2.5, but it did. So if I go ahead and I draw that median, I can count. It's 1, 2.5, because we determined that this is a halfway point. So the median is equal to 2.5 altogether. Well, I'm going to divide that by 3. And I'm going to get 0.83 repeating. So, okay, my midpoint here is 6, 2.5. I need to go up this far. Okay, so I've got 6, 2.5 is my midpoint. I want to go up. Up is on the y-axis. So I'm going to add 0.83 repeating to this 2.5. So far, are you guys following me? Or did I completely lose you? The 3, that comes from earlier in the notes. I'll give it, you can, yeah. So I'm going to have a 6 because I'm not changing right and left. I'm only changing up, down. So I'm changing to go up. So the 6 will stay the same. The repeating 3, 5 and 8 is 13. Carry my 1. So this is my centroid. We have an altitude. Altitude is the same thing as height. The altitude of a triangle is a line segment from a vertex perpendicular to the opposite side. So we have from vertex perpendicular to opposite side. And what happens is sometimes you have to go outside of the triangle to get there. For example, in this triangle, there's no way I could draw a line from this vertex inside this triangle and be perpendicular. You guys can all see that, right? Like from here, I can only go straight down to be perpendicular. So sometimes the altitude goes outside of the triangle, and so that's why it says to the line containing the opposite side. What we've done here is we extend the length of the side in order to get that altitude. Okay, so an altitude is always from a vertex and it's always perpendicular. Not to be confused with a perpendicular bisector, which is always perpendicular but not always from a vertex. So, we'll go over these all, like I said, we'll go over them all together too, like at one time. So they're the height of the triangle. Now an altitude and a perpendicular bisector and a median can all be the same line. They just don't all have to be the same line. Okay, but if I have like an isosceles or an equilateral triangle, my altitude from, if I'm talking isosceles, my altitude from the vertex angle is also a perpendicular bisector and it's also a median. But if I'm talking about, just like any old regular scaling triangle, that's not the case. Okay. When you're inside the triangle, it's because you are 90 degrees or less on your altitude. So these are 90 degrees or less. And when you fall outside is when you have your obtuse triangle. Now, not every altitude will necessarily be outside on an obtuse triangle. Maybe only one is. But if you look at this particular triangle here, this is one altitude. This is the other. This yellow highlighted. Because from this vertex perpendicular to the opposite side. Nope, I'm lying. That's not. Ignore me. I hate it when I lie to you guys. It would be more over here, sorry. Just ignore me sometimes. Okay, what we have, every triangle has 3 altitudes. Just like every triangle has 3 medians, every triangle has 3 perpendicular bisectors, every triangle has 3 angle bisectors. We all have 3 altitudes as well. And the orthocenter is where those altitudes meet. Okay, so the orthocenter is where the altitudes meet. And so we've had perpendicular bisectors, and perpendicular bisectors meet at the circumcenter. We have angle bisectors that meet at the incenter. We have medians that meet at the centroid, and now we have altitudes which meet at the orthocenter. So see what I mean when I said that the hardest part of this chapter is going to be kind of keeping which goes with which together and straight. The orthocenter can be inside, outside, or on the side of a triangle. When it's inside is when you're acute. When it's outside, you're obtuse. And when it's on the side, you're a right triangle. And that makes sense, right? Because it's perpendicular to this side, so there's your perpendicular, perpendicular, and then you just draw one from here, and that's perpendicular. So acute orthocenters are inside, obtuse orthocenters are outside, and then right orthocenters are on the corner of the right angle. So if I give you any right triangle and I say, where's the orthocenter, you just go, like, here's your right triangle, you just go, there it is. You don't have to do any work because it'll always be on that right triangle's right angle corner. So those are nice. Any questions on that? There's absolutely nothing special about an orthocenter. Where we had the centroid and the incenter and the circumcenter, they had like relationships with the lengths and all that stuff. Orthocenter's just there. Doesn't do anything. There's no relationship between any of the lengths anywhere. The only thing you can say is it's perpendicular to the other side. That's it. It's this point, and it's at where the lines meet, and it's perpendicular to the other sides. That's it. But we can find it. Okay, so this is on page 13. This is, no, it's not. I lied. This is not on page 13. I've got -2, 4. That's F. I've got 4, 4. That's G. And I've got 1, -2. That's H. This is not on your paper anywhere. Apparently I'm lying a lot today. It is the lack of sleep. You're absolutely right, it's the lack of sleep. Okay, so to find the orthocenter, the first thing we want to do is find the slope, because we're looking for perpendicular lines, right? So we want to find the slopes. Okay, well this slope of FG is easy. FG is 0. It's flat. Found that slope. No problem. Okay, the slope of FH. Okay, remember the slope formula is subtract the y's, y1 minus y2, or y2 minus y1, and then x1 minus x2, or vice versa, as long as you keep them in the same order. 1's first or 2's first. Doesn't matter which. Okay, FH is going to be 4 minus -2 and -2 minus 1. So I have 6 over -3, so that's -2 is that slope. And then GH is going to give me 4 minus 1 over, I lied again, 4 minus -2 over 4 minus 1, so that's going to give me 6 over 3, which is +2. So I found my slopes. Okay. Now I need to find, okay, now the perpendicular slope here is easy because that's a straight vertical line. So my altitude for H is just like that. So I found that one. Okay. Now I need to find either G perpendicular to FH or F perpendicular to GH. Up to you. perpendicular to GH? Okay, so I've got this point here, and I need it to be perpendicular over here. So this line is 2. I need my slope that's perpendicular to be -1/2. Okay. My point F is -2, 4. I want my slope to be -1/2. Slope is y1 minus y2 over x1 minus x2. I have 1 point. So if I do, say, 4 minus y over -2 minus x, 4 minus y has to equal -1, and -2 minus x has to equal 2, because it has to equal this fraction. Okay? So -y equals -5, so y equals +5. -x equals 4, so x equals -4. I just kind of solved. So I go to -4 up to 5, and that's where my perpendicular line is going to fall. So I can draw this line through that point to the other side, and it's perpendicular. I'm not drawing it very well, but I think it's supposed to hit right there. Where those two lines meet is your orthocenter. So this is 1, 3. Okay, so you just had to find another point that makes a perpendicular line, and then connect them and draw your line. And then find where the two lines meet. So for homework, page 14, 1 through 17. See you tomorrow.